Mastering unsupervised learning. K-means clustering ruthlessly segregates data into distinct cliques based on their inherent rivalries. Who can explain the process by which K-means clustering, an unsupervised learning algorithm, partitions the data into distinct clusters based on their similarities and differences, and what are the key steps involved in this process? K-means clustering is an unsupervised learning algorithm that partitions the data into distinct clusters based on their similarities and differences. The process involves the following key steps. Step 1. Data preparation. The first step is to prepare the data by scaling and normalizing the features to prevent features with large ranges from dominating the clustering process. This is done to ensure that all features are on the same scale and have equal importance in the clustering process. Step 2. Initialization of centroids. Initially, K-centroids, also known as cluster centers, are randomly selected from the data points. The number of centroids, K, is a hyperparameter that needs to be specified before the clustering process begins. These centroids represent the initial guesses for the cluster centers. Step 3. Assignment of data points to clusters. Each data point is assigned to the cluster whose centroid is closest to it. The distance between a data point and a centroid is typically measured using the Euclidean distance metric. The data point is assigned to the cluster with the minimum distance. Step 4. Calculation of new centroids. The centroid of each cluster is recalculated as the mean of all data points assigned to that cluster. This is done to update the centroid positions to better represent the clusters. Step 5. Convergence check. The algorithm checks for convergence by verifying if the centroids have changed significantly from the previous iteration. If the centroids have converged, the algorithm terminates, otherwise, steps 3 and 4 are repeated until convergence is reached. Step 6. Cluster refining. Once the centroids have converged, each data point is re-examined, and its cluster assignment is refined based on the new centroid positions. This refining process helps to improve the quality of the clusters. Key aspects of K-means clustering. Some key aspects of K-means clustering are: K-selection. The choice of K affects the clustering outcome. A large K may result in over-partitioning the data, while a small K may result in under-partitioning. Centroid initialization. The initial placement of centroids affects the clustering outcome. The K-means ++ algorithm is often used to initialize the centroids in a way that speeds up convergence. Cluster quality. The quality of the clusters can be evaluated using metrics such as silhouette scores, Kalinske-Harabas index, or Davis-Bolden index. Challenges and limitations of K-means clustering. K-means clustering has some challenges and limitations. Sensitive to initial placement of centroids. The algorithm is sensitive to the initial placement of centroids, and different initial positions may result in different clustering outcomes. Sensitive to outliers. K-means clustering is sensitive to outliers, which can significantly affect the centroid positions. Assumes spherical clusters. K-means clustering assumes that the clusters are spherical in shape, which may not always be the case in real-world data. In summary, K-means clustering is a powerful unsupervised learning algorithm that partitions the data into distinct clusters based on their similarities and differences. The process involves data preparation, initialization of centroids, assignment of data points to clusters, calculation of new centroids, convergence check, and cluster refining. However, the algorithm has some challenges and limitations that need to be considered when applying it to real-world data.